Exchange 106 towers 453.6 meters over Kuala Lumpur, governed by an invisible digital architecture as sophisticated as the steel and glass framework visible from the street. Many high-rises rely on reactive, siloed mechanical systems. Their air conditioning, the lighting grids, and fire alarms often operate on parallel tracks, unable to communicate with one another. In a skyscraper holding thousands of people, these disconnected systems create risks. Without integration, a ventilation system might continue pumping fresh oxygen into a fire simply because it hasn't received a signal to stop. The Intelligent Building Management System, or IBMS, represents a shift toward connectivity. It bridges the gap between hardware and software, turning a physical structure into a responsive network. Instead of reacting to failures after they happen, the building monitors its own health in real time. It analyzes data patterns to forecast a pump failure weeks in advance, or adjusts cooling based on actual occupancy levels. Safely maintaining a tower of this scale requires moving away from patchwork components. To function effectively, the entire structure must think and react as a single living organism. This diagram shows the network architecture of the Honeywell Enterprise Building Integrator, or EBI. As Exchange 106's digital brain, it manages energy distribution, optimizes the central cooling, and automates lighting. Critical life safety systems are also wired here, syncing fire suppression directly with security. By unifying these systems, the AI establishes a baseline for normal operations. It uses machine learning to flag abnormal trends, like irregular movement patterns or subtle drops in water pressure, allowing for maintenance before a fault occurs. Unifying these systems removes the blind spots found in traditional buildings. The tower proactively optimizes its energy use and protects its occupants, moving beyond simple alarm monitoring. This 5-stage EB operation protocol shows how the building's nervous system functions. It begins when a physical sensor detects a shift, like heat or smoke. This raw data travels instantly over a fiber optic backbone directly to the EBI main server. In less than a second, that data reaches the operator level. This is an actual view of the security control room, where the central display wall visualizes live system feeds for the monitoring team. The building can also act without human input. Automated logic in the EBI brain can immediately activate stack pressure fans to contain smoke, while simultaneously unlocking fire doors for safe egress. This millisecond workflow changes how the building handles emergencies. The tower takes active measures to suppress a crisis on its own, often containing a threat before first responders arrive. Looking at this master layout map, you can see Exchange 106 is one part of the 70-acre Tun Razak Exchange, a massive transit-oriented development. Managing a district of this size requires a higher-level command framework known as the TRX Integrated Management System, or TIMS. This enables the final stage, City Sync. Exchange 106 feeds its internal data up to the TIMS hub, allowing for district-wide coordination. In an emergency, TIMS can isolate utilities or reroute traffic across the entire smart city grid. This ecosystem provides clear environmental benefits. AI-driven optimization helps the building exceed Green Building Index energy standards by reducing waste across the entire development. For the people living and working here, these systems provide a level of comfort and safety that goes beyond basic regulatory compliance. As skyscrapers reach higher into the clouds, the benchmark for success has shifted toward the depth of the digital intelligence managing the life within them.